lang gyud. Mhm. Okay, we're done with the explaining how heat transfer and energy transformation make heat and engines work, illustrate the parts of a heat engine, solve problems related to work and heat. So for this afternoon, we are going to elaborate on the different laws of thermodynamics. Okay, so please get your textbook and go to page 424 to 427. It's about the different laws of thermodynamics. Okay. To start with, let us understand what is a law. Okay. So I'm referring to scientific laws. So if you notice, no, in science, specifically in physics, we have different laws. Okay. So when we say law, it is a description of a natural phenomenon. So this is how nature works. Okay. This is based on facts. It has been proven, have evidence and result, well supported with evidence, and have been tested repeatedly over time. Okay, so that is the definition of scientific law. So heat engine is governed by three, okay, laws. So we have the first law, second, and then third law. Actually, there is fourth law, which is the zeroth law of thermodynamics, but we will not include that in our lesson. Let's have the first, second, and third law. Okay. So let's start off with the first law of thermodynamics. By the way, you need to listen because later on we'll have the short quiz, 10 items quiz. So first law of thermodynamics, if we are going to apply that to heat engine, this is the diagram. Are you familiar with this diagram? I believe wala pa mo ani ka-encounter. So this is the schematic diagram for the energy flow of a heat engine. Okay? So dili in ani gud ang porma sa heat engine. Okay? Schematic diagram ra ni siya of how the energy flows in a heat engine. Okay? So again, when we say heat engine, unsa gali ang heat engine class? Please use your microphone. What is a heat engine? It is a device that anyone?
uses heat
Okay.
energy to to transform to mechanical energy.
Okay. So it transform heat energy to mechanical energy or work. Okay. So in this diagram, you will notice that we have two reservoirs. Okay. The hot reservoir that will be our source of heat at certain temperature, high temperature. Of course, kay init man na siya. And then we have also cold reservoir. This will be our sink. Okay. And then we have the heat input represented by QH. And then we have the heat output, okay, represented by QC. Okay, if you notice, the heat input here will be converted to work using engine. Okay, but not all the heat input will be converted to work 100%. No, there will be a percentage of energy that will be wasted. Okay? So, ang among term ana is cold reservoir or the sink. Okay? So, in first law of thermodynamics, it expresses the principle of conservation of energy. Okay? So, first law of dynamics, thermodynamics is just similar with what we know as the conservation of energy. 'Di ba? It states that energy can neither be created nor destroyed. It can only be transformed from one form to another. Okay, so that is similar with the first law of thermodynamics. So it simply states that part of the heat transferred to an object is used by the object to do work. Okay, so not all the heat input is converted to work. Okay, nagyo na siya waste. Okay, and that is distributed to the environment. And we call that the cold reservoir. So this will be the mathematical expression if you are going to solve for this one using the heat input and heat output. Okay, so heat input minus heat output is equal to work done. Okay, so we can rearrange that one if you are going to solve the heat input. So heat input is equal to heat output plus work done. Okay, let's say for instance our heat input is, let's say, oh yes, saan na yan? Let's say our heat input is 50, okay, nawala siya. 50 joules. For example lang ha, 50 joules. Our QH is 50 joules. And then our work done is, let's say that is 30 joules. The value of our Q output, QC. What do you think is the value of our QC? If our QH is 50 and our work done is 30. So pila man ang value QC?
20 joules.
Okay, very good. 20 joules. Okay? Remember, our QH is 50. Diba? And then our QC is unknown. Dayon, atong work done is 30. Equal man dapat siya sa 50. So, i-minus lang. 50 minus 30. So, 20 joules. Okay? So, meaning to say, the energy input is equal to the energy output plus the work done. So, energy is conserved. By the way, nasa ko i-accept. Magina akong giyon. Dili mag-late. Okay, let's go back. Okay, am I clear with the first law of thermodynamics? So, okay, I'll give an example for first law of thermodynamics applied in a car engine. Okay, so part of the energy supplied by the gasoline or diesel is transformed into useful work, of course, to move the vehicle. Okay, so some of the energy heats up the car while the rest is given off as a heat in exhaust gases. So kana siyang aso-aso sa sakyanan, okay, is the exhaust gases, and that is distributed to the surrounding air or the environment. So asa dadto ang heat source or heat input. So that will be the burning of gases or gasoline rather, and the heat sink is the surrounding air. Okay? So am I clear for the first law of thermodynamics? Okay, remember, first law of thermodynamics is just similar with the conservation of energy. Okay? Hello, 9H? Clear na
Yes,
for
ma'am.
first law? Okay, let's proceed to the second law of thermodynamics. Okay, second law of thermodynamics limits the amount of work a heat engine can do for a certain amount of heat. So just like what I said a while ago, that not all the heat input is converted to 100%. Okay, naagyoy mabilin na waste. Okay? So there are three versions in explaining the second law of thermodynamics. So we have from Kelvin Planck statement that no heat engine can completely convert heat energy to work. Okay, that is true. Next, second version from Clausius. Heat flows naturally from hot to cold objects. Okay? So naturally, the heat will flow from higher temperature body to low temperature body. Example, if a glass of water is placed on a table, 'di ba, the glass of hot water cools by itself later because what will happen to the heat energy? It is transferred to the surroundings. Okay? So if there is temperature difference, mo-flow gyud ang thermal energy and we call that heat transfer. Okay? So it will naturally flow from high to low body or temperature body. Okay? So that is for Clausius. Next is the entropy statement. So when a reversible process occurs, the total entropy of the universe remains the same. When an irreversible occurs, the total entropy of the universe increases. So what does it mean? When we say entropy, that is the measure of um, system disorder or messiness. Okay, let's say for example, 'di ba, it says here reversible process occurs. So reversible, the total entropy will be the same. Example, solid metal can be melted. Okay, for example, gold. Pwede siya ma-melt and then cool down to form solid metal again. Okay? Pwede siya in liquid, pwede po siya ma-solid. Ma-reverse ang process. So which means to say that the total entropy or the measure of system disorder is the same. Okay? But if it's irreversible, example, you cook egg, okay, you fry an egg, it can never be a raw egg again. So dili na nimo siya mabalik to raw egg again pag makaluto na ka og egg. Okay, sunny side up na egg. So therefore, the entropy is increasing. Okay, and that is true. That is true because, for example, if you're going to spray perfume inside a room, what will happen? 'Di ba mukalat man ang baho? So meaning to say, the particles are disordered. Okay? Messy siya, mukalat siya, in which it is increasing. Okay? Kay mag-start siya from order to disorder, then that is increasing in entropy. Okay? Pag mugubot siyang maayo, ang tawag ana is increasing entropy. Of course, in gaseous state, di ba, molecules will move randomly compared to solid and to liquid state. So, mas increasing ang entropy. Mo-increase ang entropy sa gaseous compared to liquid and solid state. Okay? So, that is for the entropy statement. So, from order to disorder. Okay? Ang flow of the energy. Okay? So, these are the three versions of the second law of thermodynamics. Okay. So question, is it possible to transfer energy from a cold body to a hot body? Yes or no? Anyone?
No.
Okay, no. Okay, correct. No. Naturally. But there's an unnatural process. Okay, pwede nato na siya mabali, ma-reverse using work. Kailangan ka mag-exert og work. And unsa na device pwede na siya. Are you familiar with heat pump? Heat pump in refrigerator, heat pump in air conditioner. Okay? So, natay ginatawag og heat pump. Okay? So, possible siya from cold to hot body. But this is an unnatural process. Okay? But naturally, dili na siya pwede gyud. It's impossible. Pero since high-tech naman ta karon, no, we can do that in a natural process, then pwede using heat pump. Okay? So asa man ni siya makita ang heat pump, just like what I said a while ago, muna siya sa refrigerator and sa air conditioner. Okay, what's the purpose of heat pump? Ang buhaton niya is na natin ginatawag og liquid refrigerant. Sila ang mag-absorb sa heat that is present inside the refrigerator or in air conditioner. Then ilang buhaton is i-absorb nila ang heat and they will distribute it outside. Ipagawas na nila. Okay? Kaning heat pump, this is just the same with water pump. Pero in heat pump, iyang kwaon o iyang i-absorb is just the heat. Ipagawaso na niya sa refrigerator. Okay? That is why isira gina siya pag dili gamiton kay para dili siya mo consume og greater electricity. Okay? Kay mudako man iyang work. Okay? Pagdagan na heat inside the refrigerator. So mas mudaghan iyang trabaho to absorb all the heat and then ipagawas niya sa environment. Okay? So that is heat pump. So this will be the diagram analysis of a heat pump. So it's like the reverse process of a heat engine. Okay? 'Di ba sa heat engine, it will flow from high temperature to low temperature. Dayon, it will be converted to mechanical work for heat engine. But for this one, for heat pump, lahi siya. You need to apply work using motors. And then, what will happen to cool energy, high temperature, low temperature, ipagawas niya sa high temperature. So, in the case of refrigerator, what is the QC there? 'Di ba mao man ang sulod sa refrigerator? Of course, lower in temperature compare sa gawas. Okay? Kanida yung QH, that will be the environment sa gawas sa refrigerator. Kanang sa likod bitaw, kabantay mo ng init na part, diyan niya i-release ang na-absorb niya na heat. So, the heat pump is the opposite of the heat engine. Okay? So the second law of thermodynamics determines the preferred direction of a process. Kung sa first law of thermodynamics, it tells us the conservation of energy. Diri pod sa second law of thermodynamics, it tells us the direction of the energy. Okay? Am I clear for second law of thermodynamics? Hello? 9H?
Yes, sir.
Okay. So, kani siya second law. This is for the direction or the process of the energy unsa iyahang flow. Okay? Next, let's proceed to this question. Is there a machine that is 100% efficient? Yes or no? Nabay machine na 100% efficient?
Sure, no, sure.
Okay, no. Because just like what I said a while ago, not all the heat input is converted to work. Na jud nay waste. Okay? So let's talk about the efficiency of a heat engine. So when we say efficient, how productive, how effective heat engine is, okay? So remember, in every energy transformation, some energy is wasted, okay? And that is distributed to the surrounding air or in the environment. Since heat flows naturally from hot to cold, a certain amount of heat dissipates to the sink as waste heat, and that is the QC, okay? The heat output. So energy dissipates because, okay, or disappear because of friction between engine parts. Okay? Of course, dili lang kay convert niya to work tanan energy. So possibly na friction. Okay? So diya pod na distribute ang energy. Okay? So how much is the input heat is converted to work determines the thermal efficiency of heat engine. So how can we calculate thermal efficiency of a heat engine? So we can use this equation. So by the way, when we say thermal efficiency, it is defined as the ratio of output work to input energy or heat input and is often stated as a percentage. Okay? So ang thermal efficiency is presented using percentage. Okay? So we can solve the thermal efficiency using this equation. Output work divided by the input energy or heat input times 100. Okay? So, mo na siyang symbol. Work divided by QH, that's the heat input, times 100. So, sa inyong textbook, it is HH. So, again, sa atong heat, let's use the symbol of Q. Okay? So, heat input Q, H times 100. Or, pwede na nato siya gamiton atong QH minus QC. Sure, nga nung nahimo man ang QH minus QC? Because work is equal to QH minus QC. Katong sa first law of thermodynamics, di ba? Work done is equal to heat input minus heat output. So instead of kani, W, you can use this para i-replace dira. Okay? So QH minus QC divide by QH times 100. So please take note of the formula for thermal efficiency. Okay? Let's proceed. Let's have this sample problem. An internal combustion engine having a thermal efficiency of 20% produces 2,500 joules of work. How much is the input heat? And how much heat does the engine reject? Okay, so let's start with identifying what are the given in this problem. Sige, anyone? Sige, participate.
Thermal efficiency,
Okay, thermal efficiency, pilang value?
25%.
Okay, 25%. What else aside from the thermal efficiency?
Work 2,500 joules.
Okay, 2005 efficiency. Okay, correct. 25% and then work done. We have 2,500 joules. Okay, how much is the input heat? Okay, what is the symbol for input heat?
QH,
Okay, QH. Okay. So let us for QH. Unsa na formula gamiton to solve? Asa to na
Heat
formula?
output plus work done.
Mhm.
itong thermal efficiency
Sure ka
equal
to.
to
Output over heat
Okay,
times
thermal
100
efficiency. Okay, thermal efficiency is equal times 100. Okay? So what is the value of our thermal efficiency? 'Di ba 25% given man na. Work 2,500. Ano tapos times 100. Next step is to para mawala ni 100, ano ni i-divide both sides by what?
100.
100.
Okay, 100. Cancel, cancel. So 25 divide by 100. Pila?
0.25.
1.25.
125, 0.25.
0.25.
Okay. So dali na lang ako isumpay. 0.25 is equal to 2,500 joules. Uy, happened. 500 joules divide by QH. Dayon, cross multiply QH times 0.25, 2,500 joules. What's your answer? Divide both sides by 0.25. Ilan yung value?
10,000
Okay, 10,000 watt sa
joules.
unit. Joules. Okay. Joules man ang nabilin na unit. Okay, so our QH or the input heat is 10,000 joules. Or pwede na siya 1.00 times 10 to the power of 4. Okay, so you move lang to the left 4 times para may mo siyang 1.0 times 10 to the power of 4 joules. Any question for A? Hello?
None.
Okay. What about for B? Ay, say accept sa nako ganina rin siya. Insan eh. Okay, iyan. For letter B, how much heat does the engine reject? Okay, so for B.
Itong first law. Thermal
Okay, so what's the formula
work
for
done is
first law?
equal Q hot minus Q cold.
Okay, minus Q cold. Okay, so let us now substitute work done is ato sang i-rearrange. So QC now is equal to work or QH minus what QH minus work. Okay? So QC pilang QH given
10,000 joules.
10,000 minus work 2,500. Okay, so what is the value of our heat output?
7,500.
7,500.
Okay, 7,500. Okay, question. Kindly screenshot 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Okay, let's proceed to another sample problem. Practice exercise. Okay, an engine receives 3,850 joules of heat and discards 2,250 joules to the atmosphere. A, how much work is done by this engine, and then what is its thermal efficiency? Okay, what are the given? Identify sa.
Q hot equals 3,850 joules.
Okay, given engine receives. Okay, so that is QH. Eight else.
QC 2,250 joules.
Okay, discard galing, gipagawas. Okay, QC is 2 joules. So, required, you need to find the work
Work.
done. And then for B, thermal efficiency. Okay, unknown. So, solution for work.
QH minus
QH
QC.
minus QC.
Okay. Ilan yung answer?
1,600.
So, wait lang ako sa it, right. Minus 1,600
600.
joules. Okay, so that's the answer for work. Now, let's proceed to thermal efficiency for B. Formula is TE na lang kibutang ha kay taas kayo.
Output work over input energy times 100.
Okay. Substitute lang dayon. 16 QH is 3,850 times 100.
41.56.
Same, 41.56. How about the others? Pareha mo? Ay,
Let's see.
naka-multiply na siya. Wala pa no.
Multiply.
Apil na?
Let's see.
That's true.
Okay, so percent na siya. Cancel naman din eh. Wait lang. E. Okay, kindly screenshot. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Let's proceed to third law of thermodynamics for a while. Sa third law of thermodynamics, it's more on the absolute value of Kelvin. Wait lang, naku, di pang tao. Okay, let's proceed. Third law of thermodynamics. So this one is for absolute zero. Are you familiar with absolute zero, class? Hello? Absolute zero? Hello?
No?
In chemistry, 'di ba ang temperature degree Celsius, ang equivalent sa absolute zero, 'di ba sa Kelvin man na? If you convert that to degree Celsius, 'di ba -273.15, ang 0 Kelvin is equivalent to -273.15 degrees Celsius. Okay? So the third law of thermodynamics is the discovery of absolute zero. So it states that it is impossible to lower the temperature to 0 Kelvin. Thus, even ideal efficiency cannot be 100%. So this one, iyang i-present ang efficiency through temperature. Di ba ganina kay thermal efficiency, we use the energy. This one, it was Sadi Carnot, the father of thermodynamics, a French physicist who calculated the efficiency in terms of temperature. So instead of using energy para isolve ang efficiency, he used the temperature, okay, using the Kelvin scale. Okay. So the efficiency called ideal efficiency of Carnot engine whose hot reservoir is at temperature TH and whose cold reservoir is at temperature TC. Okay, so this will be the equation if we are going to solve for the ideal efficiency. So TH minus TC divided by TH. Actually, similar naman siya in terms of energy. Di ba sa energy kay QH minus QC divide by TH. But this one is in temperature lang. Okay, using the Kelvin scale. So if ang given is in degrees Celsius, you need to convert that to Kelvin. Okay? So note that TH and TC must be expressed in Kelvin. Okay? Because if we go back to the definition of temperature, di ba, that is the movement of the molecules or the particles. If the movement of the particles is fast, what will be the temperature, hot or cold?
hot,
Hot.
Okay, hot. If the movement of that particles is slow, then the temperature is
cold,
okay, cold. But what if there is no movement? What if daw wala na nag-move ang particles? Unsay tawag? You cannot say na low temperature or cold. You cannot also say that high temperature or hot. Kaya naman na sila motion of the particles. So, unsay tawag na to, ana? So, ang tawag din nila, ana, is absolute zero. Okay? Wherein the particles will not move. Okay? Mo na ang na-discover ni Nicolas Sadi Carnot. Okay? It is impossible to lower the temperature to 0 Kelvin. So, let's try this. Wait. This problem. Okay, answer sani. How do thermal efficiency and ideal efficiency differ? Sa kalainan nila,
In
anyone?
energy, thermal efficiency and ideal efficiency is temperature.
Okay, very good. Calculated using energies, while ideal is calculated using temperature. Okay, so mao na ilang kalainan. So let us try the ideal efficiency na mga sample problems. Okay, can you read Ian, first problem? Ian. Time is it? 1:05. Hello, Ian.
Sure, siya yung mic.
Okay. Ikaw na lang, Marinel.
Sige, sure. An ideal engine has an efficiency of 28% when the temperature of its hot reservoir is 120 degrees Celsius. What is the temperature of its cold reservoir? How much work did this engine do for an input energy of 5,500 joules?
Okay. So what are the given in this problem? Given?
Ideal efficiency 28.
28%,
Okay. Ideal efficiency, 28%. Excuse, what else?
TC 128 degrees Celsius.
TC or TH?
TH day.
Okay.
TH,
TH. So 120 degrees Celsius. So what is asked, required in this problem?
TC,
Work
Okay. TC and
work,
work. Okay. So let's solve using what formula? Mm-hmm.
TH minus TC over TH times 100.
Okay. Kuan ideal efficiency. IE na lang ha. TH minus TC divide by TH times 100. Okay, TH na by TC, unknown pa man. So, atong buhaton is, by the way, TH minus TC divide by TH, we can rewrite that as TH over TH minus TH. Okay ba? Nasabtan? Hello?
Yes.
Okay. TH minus TH is equivalent to pila.
Zero.
Example, 1 over 1 na siya.
A one.
Okay, so
1.
1. So, pwede ra 1 minus TC over TH. Okay? Bariya lagi na siya, kani, o kani. Same ra na sila. Okay? But in this problem, kanitong gamiton para dali. Okay? So, ideal efficiency is equal to 1 minus TC divide by TH times 100. So, pila ang given ideal efficiency? Diba, 28%. Dayon, 1 minus TC divide by TH is, ikuan sa ni Kelvin. 120 plus 273. I-add sa
393 Kelvin.
393. Okay, so 393 Kelvin times 100. Okay, next step. So, yung next buhan. Para mawala ang 100.
One
Divide.
times 100.
Okay, divide by 100. So, cancel, cancel. 28 divide by 100.
0.28.
Okay, 0.28. Then, may mo siyang 1 minus TC divide by 393 Kelvin. Okay, next na to buhaton is transpose nato ni silang duha. Kani kay na may 1 minus, di maka-multiply ana. So, may mo siyang, ito naman, TC, di ba, from negative, may mo siyang positive, ibalin nato siya sa left side. 393 Kelvin equal to 1 minus, kanipod siya, may mong positive, may mong negative, kung ibalin siya sa right side. So, minus 0.28. So, 1 minus 0.28, pila?
0.72.
Okay, 0.72. So, diri na lang ako i-write. 0.72. Then, TC, so to, TC over 393. Okay, cross-multiply lang dayon. Or pwede rin na siya isa ka. Mhm. Ito ba? So, 0.72 times 393K. Ilan yung answer?
282.96.
282.96.
96.
Unsa ang unit? Hello.
Kelvin.
Okay?
Kelvin, temperature mo na.
Malimot ko.
Okay, kindly screenshot.
Sis Peter, pwede pabalik atong slide sa difference sa thermal o
Kani,
ideal efficiency siya.
kani?
Ano siya? Think.
So, 18 point. Okay na?
Next one.
2A. Any question for this? Ani? Kindly screenshot na lang. Question? Tas gid siya, no? Okay, none. This one, screenshot. Okay. Then this one, this will serve as your assignment. And ang practice exercise 18.3. We will check that together next meeting. Then you're going to answer the quiz. 10 items naman na siya, dali ra na. Walay solving ana. You may start na for the quiz. And then assignment na tong practice exercise 18.3. Go. Yes, Lawrence, na siya sa book. Laws of Thermodynamics. Latin na lang, Lawrence. Passing score is 5. So far, only one got perfect. We have Vaughn, followed by 9. Miles, Russell, Aliana 8, Rupert 7, Ira 7, Marinelle 8, Janessa 7, 9, Ian 8. Ang uban kay madlok na og submit. Let me check your smiles. Naa kay isa gyud nga wrong. Time check 1:18. Angel 8, Pauline 8, Ian 8, Nor 7, Jade 8, Gab 8, who is absent? Bido. Nabay absent. I only decipher. Thank you. Candy 9, makita mo asa ka na wrong Miles? No? Dili?
Dili siya.
Dadto ka sa katong na picture.
Thank you,
Okay.
sir.
Kate 10. Very good. Locking 2. Okay, let's have our closing prayer.